Air separation unit, an industrial facility used to separate atmospheric air into its primary components. Air is mostly a mixture of nitrogen, oxygen, and argon. These elements can be directly recovered in gaseous or liquid form by passing the ambient air through an air separation unit, or ASU. The process starts with the ambient air being forced through a particulate filter. This filter traps dust and other small airborne particles. Next, the air is compressed with a compressor 6 times normal air pressure. This is done in preparation for the initial cooling. Because the air has just been compressed, its temperature will increase. The air coming out of the compressor is now at a higher pressure and temperature, from 20 degrees Celsius to about 90 degrees Celsius. This high-pressure hot air is then passed through a heat exchanger, which is cooled by cold water directly interacting with the air. The temperature of the air drops to 10 degrees Celsius while the pressure only drops a little. Now we have high-pressure air that's a little bit below ambient temperature. Before we can cool the air further, we must remove any gas or liquid vapor that will turn solid before we reach our lowest temperature of minus 196 degrees Celsius. This is mostly CO2, which would turn to dry ice. These solids could block the air flowing through the system. We must also remove hydrocarbons, which are flammable when mixed with pure oxygen. To remove all of these items before we cool the air further, we pass the air through a temperature swing adsorber. These are pellets that are designed to absorb CO2 and other unwanted compounds. These compounds are adsorbed, not absorbed, by the pellets. That is, they only stick to the surface of the pellets. And because of this, the adsorbed materials are easily released from the pellets when the pellets are heated. There are 2 tanks with these pellets. Only one tank is active at a time. The active tank is cooled with liquid nitrogen, keeping the pellets cool as they adsorb the unwanted compounds. When the pellets become saturated, the active tank is deactivated and the air now flows to the second tank, which is now the active tank. This tank is now cooled while the deactivated tank is allowed to warm up. As the air warms up, the CO2 and other compounds are released from the pellets, preparing them to accept the flow of air once again after it's cooled. After the air passes through the temperature swing adsorber, it is now composed of only nitrogen, oxygen, and argon. It's now ready to be cooled to cryogenic temperatures. The air is passed through a Joule-Thomson cooler. This kind of cooler takes advantage of the Joule-Thomson effect. When a gas expands in thermal isolation, its temperature will drop, so by passing the high-pressure air through an expansion valve, we reduce the temperature to minus 120 degrees Celsius. By using this cooled air to pre-cooled incoming air before the expansion valve, we're able to further cool the air down to minus 165 degrees Celsius. We now introduce this cooled air into the cold box. This is where the air separation actually happens. The cold box has 2 chambers, high pressure at the bottom and low pressure at the top. The bottom section is pre-cooled to minus 173 degrees Celsius. When the cooled air enters this chamber, the oxygen and argon will liquefy at the bottom. This liquid is also called crude liquid oxygen, or crude LOX. Gaseous nitrogen is available for collection at the top of the chamber. It's also passed through a reboiler condenser that turns the gaseous nitrogen into liquid. This liquid is fed to the upper low pressure chamber. There, it cools the top of the chamber to minus 196 degrees Celsius. When we then introduce the crude liquid oxygen, it will flow to the bottom of the low pressure chamber, which is at a higher temperature of minus 179 degrees Celsius. At the bottom, it will slowly turn into vapor. Since the boiling point of argon is lower than that of oxygen, it will remain a gas while the oxygen turns into liquid as both gases rise from the liquid and get colder, thus separating the two. So, in the end, We can extract liquid oxygen at the bottom of the tank, gaseous argon in the middle, and gaseous nitrogen at the top.